Hey guys, we're going to review a couple things with relations and functions and then learn a few more. So a reminder, a relation is a set of ordered pairs, so x's and y's, and then a function is a specific relation where every input is given exactly one output. Another reminder for functions, that it passes a vertical line test. So an inverse relation is where we're going to take our ordered pairs and we're going to reverse our coordinates. So if I had a comma b, the inverse would become b comma a. A couple notes, the inverse might not be a function, but if our relation and the inverse are both functions, then we refer to them as inverse functions of one another. So here I am given a table. It's a relation because I have my inputs repeating, but my directions say to find the inverse. Well, we said that our coordinates swap to find the inverse, so my inverse table would look like this. Notice my y values became my x values, and my x values became my y's. I went ahead and graphed these. The black dots are the original relation. The pink dots are the inverse. And if you notice, the dots are reflected over the line y equals x. Whenever you're talking about inverses on a graph, they will always be a reflection over that line y equals x. We can also find the inverse algebraically. So here we're given an equation, 2x plus 6 equals y. And we need to find the inverse. Well, same as our coordinate points, they change, they reverse the order. We're going to reverse the order of our variables. So we flip-flop x's and y's. So now we have x equals 2y plus 6. And now we need to solve for y. So we're going to subtract 6 and then divide everything by 2. So our equation is y equals 1/2 x minus 3. And then one more thing. We talked about vertical line test. We know that if it passes a vertical line test, it is a function. But if we look at our original graph and we do the horizontal line test, it's the same thing as a vertical line test, only we draw our lines horizontally. If it passes a horizontal line test, then the inverse will also be a function. So for a quick example here, if this is my original relation, I can use the vertical line test to test whether it's a function. And if I were to draw vertical lines in, yes, this line is a function. But now I want to see if I reflected it over the line y equals x and found the inverse, would the inverse be a function? So for that question, I use a horizontal line test. So when I draw horizontal lines across this graph, would it pass? And it would. So we know that our original graph right here, this relation is a function because it passes a vertical line test. And our inverse is a function as well because it passes the horizontal line test.